Imagine watching a full-sized passenger bus roll forward, heavy, silent, unmistakably real, and realizing there's no fuel tank being filled, no charging cable plugged in, no visible energy source keeping it alive. No diesel, no petrol, no charging stop, just motion. That's the moment that set off one of the most polarizing debates in modern energy innovation, because if what you're seeing is even partially true, then it challenges assumptions that have guided transportation for over a century. Today's story isn't about belief. It's about claims, contradictions, and why this bus has engineers arguing behind closed doors. Maxwell Chikumbutso isn't a household name in Silicon Valley. He didn't debut this invention at a global auto show. There was no billion-dollar PR rollout, no celebrity endorsements. Instead, footage surfaced quietly, a bus operating under conditions that seemed ordinary except for one detail that changed everything. According to its creator, the bus doesn't consume fuel the way conventional vehicles do. It doesn't rely on massive battery packs designed to be recharged from the grid. Instead, it's built around a system that continuously recovers, redirects, and stabilizes energy already present during motion. That sentence alone is enough to trigger alarms in scientific circles. Because energy recovery exists, regenerative braking, heat recapture, efficiency optimization, but none of those are supposed to eliminate external input entirely. They're meant to reduce loss, not replace supply. So, how does this bus keep moving? The design, as described, treats the vehicle less like an engine and more like a closed-loop system. Motion generates recoverable energy. Heat becomes useful instead of waste. Electromagnetic interactions, usually ignored, are managed and redirected in real time, not to create energy, but to stop throwing it away. Critics are quick to point out the obvious. No system can be perfectly closed. Loss is inevitable. Entropy always wins. And yet the bus keeps running. That's where the controversy deepens. Because the most unsettling part isn't the theory, it's the lack of a clean failure point. No dramatic stall. No obvious external feed. No moment where the illusion collapses on camera. Engineers reviewing available footage don't see proof of free energy. But they also don't see the usual red flags of a staged demo. The weight is real. The motion is consistent. The behavior matches what you'd expect from a working transport vehicle, which forces an uncomfortable question. If this isn't a miracle, what is it? Some suggest hidden energy storage. Others suspect incomplete disclosure. A few argue the system may start with an external charge and simply extend it far beyond expectations. And that possibility alone is enough to make established assumptions uncomfortable. Because if a bus can dramatically reduce dependence on fuel or grid charging, even without eliminating it, then entire transport models shift. Routes change. Infrastructure planning changes. Economics change. And that's when silence becomes noticeable. No major automaker has publicly evaluated it. No global transport authority has issued a formal assessment. No definitive teardown has been allowed. Just fragments, demonstrations, and growing tension between skepticism and curiosity. Behind the scenes, conversations aren't about whether it violates physics. They're about whether it violates expectations. Because history shows us something important. Most disruptive technologies aren't rejected because they don't work. They're resisted because they don't fit. And this bus doesn't fit neatly anywhere. Not as a traditional EV. Not as a fuel-powered vehicle. Not as something easily regulated, categorized, or monetized. Which raises the most dangerous question of all. What happens if this design doesn't need permission to spread? Because once public transport operators realize that even partial independence from fuel and charging changes cost structures, the discussion moves away from, is it real, to something far more practical. Because replication is where theory collides with reality. The moment engineers start asking how to copy it, the conversation shifts from speculation to constraints. Materials, control systems, thermal limits, maintenance cycles. The things you can't fake once a vehicle is expected to operate every day, under load, with passengers on board. And that's where the bus becomes more interesting and more controversial. According to people familiar with early trials, the system isn't built around a single breakthrough component. There's no magical box, no exotic material that solves everything. Instead, it's an architecture, a way of arranging known principles so that losses are spread, captured, and reused continuously rather than wasted in bursts. In other words, it doesn't chase perfection. It chases balance. That's subtle and dangerous because balance is hard to disprove. When skeptics demand a teardown, supporters counter with operational data. When critics point to thermodynamics, defenders point to system-level efficiency rather than isolated components. Both sides are technically correct, and that's what keeps the argument alive. One transportation analyst puts it bluntly: if this thing fails, it should fail loudly. But it hasn't. Instead, what appears are patterns. Long idle times without drain. Consistent performance across routes. Minimal thermal spikes where you'd expect stress. None of this proves extraordinary claims, but none of it aligns cleanly with conventional models either. And then there's the human factor. Drivers report something unusual, but hard to quantify. The bus doesn't feel like other heavy vehicles. Acceleration is smoother. Deceleration feels assisted, not resisted. The machine behaves less like it's fighting physics and more like it's cooperating with it. That observation alone makes engineers uncomfortable because feel isn't data, but it's often the first sign that a system is doing something differently. At this point, the question isn't whether the bus runs without fuel forever. It's this: how much energy does modern transport quietly waste simply because we never designed it to care? If you assume energy is cheap and abundant, inefficiency doesn't matter. If you assume refueling is guaranteed, losses are tolerable. If you assume central infrastructure will always be there, dependence is invisible. But remove those assumptions, and suddenly, a design like this makes more sense. Not as a miracle, as a response. Which may explain why the loudest resistance isn't technical, it's institutional. Certifications don't know where to place it. Regulators don't know how to classify it. Investors don't know how to value it. Because it doesn't promise disruption tomorrow. It promises erosion over time. And erosion is far harder to stop. Still, the bus keeps moving. Routes are completed. Passengers board and disembark. Logs accumulate. And with every quiet mile, the conversation inches further away from outrage and closer to something far more dangerous to the status quo.
Curiosity.
Because once enough people stop asking, "Is this impossible?" and start asking, "What if it's just smarter?" the narrative changes. And that's when the story stops being about Maxwell Chikumbutso at all. Because imitation is the real test. Once a second team, with no connection, no shared language, no shared reputation, starts experimenting with similar architectures, the idea detaches from the inventor. It becomes a pattern others can recognize, even if they describe it differently. Small changes appear first. A transit authority experiments with deeper energy recovery. A fleet operator redesigns thermal management. A startup rethinks how motion, braking, and onboard electronics communicate. None of them call it revolutionary. None of them mention a fuel-less bus. But the direction is unmistakable. And that's when something subtle happens in the discourse. Critics stop using the word impossible. They replace it with impractical, then unscalable, then finally, not yet economical. Those are very different objections. Because impossible ends conversations. Not yet keeps them alive. Inside engineering forums, the tone shifts. Instead of dismissing the idea outright, discussions revolve around margins, percentages, trade-offs. How much recovery is realistic before complexity outweighs gains? Which quietly concedes the core point: there is something to recover. Meanwhile, the original bus continues operating, not as proof, not as spectacle, but as a reference. A living counterexample that refuses to resolve neatly into either fraud or miracle. And that ambiguity is powerful. Because as long as the system exists in that middle space, it forces a question every engineer eventually has to face. Are we sure we've already found the best way? History suggests the answer is almost always no. The internal combustion engine wasn't replaced overnight. Neither was analog replaced by digital. Progress didn't arrive as a single leap. It crept forward, disguised as optimization. This bus, controversial as it is, fits that pattern uncomfortably well. Not loud enough to declare victory. Not broken enough to dismiss. Just persistent. And persistence in engineering is dangerous. Because the longer something works, the harder it becomes to ignore, and the more expensive it becomes to pretend it doesn't matter. Somewhere down the line, a city will face a budget decision. A transport authority will compare two options. A fleet manager will choose the system that asks for less. And no one will call it a revolution. They'll call it common sense. That's why this story isn't over. Not even close. They wait while the world argues. They wait while headlines burn out and attention moves on. While critics demand absolutes and supporters overpromise futures that haven't arrived yet. And through all of it, the system does the least dramatic thing possible. It keeps working. Not perfectly, not magically, but consistently enough to survive scrutiny that lasts longer than hype ever does. And that endurance begins to create pressure in places no comment section can reach. Maintenance crews notice fewer wear cycles. Energy audits start coming back with numbers that don't match old expectations. Route planners quietly adjust assumptions they didn't realize were assumptions at all. No press releases. No announcements. Just small decisions made by people whose jobs depend on things functioning, not trending. At some point, a university lab requests access. Not to validate a miracle, but to understand a mechanism. They don't ask whether it violates physics. They ask where the losses go. They ask how the control logic responds when recovery fails. They ask how stability is maintained when variables drift. Those are serious questions. And the answers, whatever they are, matter more than belief. Because if the system turns out to be an extreme case of efficiency, not energy creation, then the implications are still profound. Transport doesn't need to break the laws of physics to break business models. It only needs to waste less than everyone else. That realization reframes everything. Fuel companies aren't threatened by one bus. Grid operators aren't disrupted by one route. Manufacturers aren't displaced by one prototype. They're challenged by a philosophy. Designed for reuse. Designed for resilience. Designed for systems, not components. And philosophies spread faster than inventions. Which explains why the resistance remains oddly quiet. Not confrontational. Just absent. No dramatic takedown. No authoritative debunking. Just a collective decision to not engage too deeply. Because engaging risks legitimizing the question. And the question is dangerous. What if we've been solving the wrong problem? Instead of asking how to generate more energy, this bus asks how to need less. Instead of racing toward bigger batteries and faster charging, it explores how to smooth demand until extremes disappear. That's not a headline-friendly breakthrough, but it's how real change happens. So the bus keeps moving. Miles turn into years. And the argument slowly loses its sharp edges. One day, someone will watch a new kind of vehicle and feel something familiar in the way it behaves, smoother, calmer, less demanding. They won't remember where they first saw the idea. They won't mention Maxwell Chikumbutso. They won't argue about fuel or physics. They'll just wonder why everything didn't work this way sooner. And by then, it won't matter who is right, because roads don't announce when they change. They just start guiding traffic differently. At first, it shows up as exceptions. Pilot programs. Limited trials labeled as experimental, so expectations stay low. The kind of projects that don't threaten anyone because they're easy to dismiss if they fail. But failure never quite arrives. Instead, what arrives is familiarity. Drivers stop talking about how strange the bus is and start talking about how reliable it feels. Schedules tighten. Delays drop. Small operational advantages accumulate until they're no longer small. And that's when comparisons begin, not in public, but in internal reports. Why does this route consume less? Why does this vehicle require fewer interventions? Why does downtime look different here? No one mentions fuel-less operation anymore. That phrase becomes irrelevant. What matters is performance under constraint. And under constraint, this system behaves well. Too well to ignore. Meanwhile, other designs begin to quietly converge. New vehicles advertise advanced recovery architectures. White papers talk about distributed efficiency and dynamic load balancing. The language changes, carefully avoiding any reference to where the idea first drew attention. But the fingerprints are there. Because once an industry senses a viable direction, it doesn't wait for permission. It reframes the idea until it feels inevitable. And somewhere in that reframing, the original controversy dissolves. The bus is no longer extraordinary. It's just early. That realization flips the story again. Because the most controversial inventions in history aren't the ones that fail spectacularly. They're the ones that succeed slowly, forcing everyone else to adapt while pretending nothing fundamental has changed. And adaptation is already happening. Cities reconsider charging infrastructure layouts. Fleet managers rethink peak demand planning. Engineers start designing for endurance instead of maximum output. All because one uncomfortable example refused to disappear. So if you're waiting for a final verdict, proof or debunking, miracle or scam, you may be waiting forever. Because the real outcome of this story won't be decided by a single test or a single authority. It will be decided quietly by adoption. And that's where this story finally rests, not with certainty, but with consequence. Because history rarely settles debates the way we expect. It doesn't issue verdicts. It doesn't announce winners. It simply moves forward, carrying with it the ideas that proved useful and leaving the rest behind. Whether this bus truly runs without fuel, or whether it represents the far edge of efficiency we've underestimated for decades, the outcome is the same. It changed the conversation. It forced engineers to look again. It forced planners to question assumptions. It forced an industry built on consumption to consider restraint. And that alone is significant. No one needs to believe every claim. No one needs to accept every explanation. Skepticism remains healthy, necessary even. But skepticism loses its power when it becomes dismissal. Because the most dangerous ideas aren't the ones that shout. They're the ones that work just well enough to be copied. If this system disappears tomorrow, the questions it raised won't. If it fails quietly, the lessons will survive. And if it succeeds, even partially, the future of transport will look back on this moment as the point where efficiency stopped being an afterthought.